Hi everyone, this is another video tutorial on Woodbee. In this video we're going to talk about converting the Woodbee toolpad to a KUKAprc toolpad, which can be run on a KUKA robot. And to do that, we're going to need a tool in order to attach that tool to the robot flange and use it as an end effector. I have prepared a geometry for my tool that I'm using, and it's very rough mesh, and don't add too much detail. Just try to be simple as possible. Make sure all the main features of your tools are there that might cause a collision with the robot or your parts. I did that as simple as I could. And also I need two planes. First one is the XY plane, which is going to be the plane of your of the flange of the robot. By the way, you also need to have the KUKAprc plugin installed so we can run the simulation using that. I'm gonna just create KUKAprc core component, and I want to show you the the plane that I'm talking about. So in this image, you have the flange here where the tool is going to be attached, and this we will consider it as an XYZ. We're not going to use a custom tool of the robot KUKAprc because the tool will be generated automatically from Woodbee. Assuming that as an XY plane, then I'm going to need the TCP as a plane, the tool center point, and this is what I have prepared already here. I had a point, which you can see in the viewport, in this center of my tool holder, and I'm using YZ plane for that. So when I attach the tool holder, it's gonna follow the same base that I have here. All right, so now we need to create our tool. So we go under Woodbee, we create a tool here. We will use the mesh of our tool. So we need to take it into Grasshopper, set one mesh, we pass it to the tool. We don't need a preview. And we're going to need a drill. The drill we already have created. So I'm going to use the same drill that I'm using in my operation. Make sure you're not using the wrong one. And the last thing is to provide your plane or TCP. Once you do that, you could already see the geometry of the tool and then the holder attached to the tool. The ID of the tool is basically the ID number of the tool in your controller, the KUKA controller. So that has to match with that. Otherwise, the robot will think that this is a different tool and won't really give you the same result. So make sure that you match up these two numbers. And you also provide a maximum spindle because the spindle set to KUKAprc is a percentage of your maximum RPM of the tool. So that also has to match with the specification of your tool. So now that I have the tool, I have to replace that in my operation. So now instead of the drill directly, we are going to use the tool, a complete tool. And wherever drill goes, like here, for example, and this one, we're going to use the tool with a combination of the tool and the drill. And now if I use the Woodbee KUKAprc integration component, it's going to take my toolpad and throw out two different things. One is the set of commands for your robot. So if I just set display that in a panel, you can see that all these are kind of KUKAprc commands. And this is also a tool. It's a KUKAprc tool. So simply, we will take our robot. This is what I use for this simulation. So we're going to plug that into our simulator. We will add our comments here, and we are going to use the tool which we provided. Then we need a number slider for simulation. And we can see now the simulation. So obviously the parts are on a really bad position. A robot cannot reach under its base, obviously. So I'm going to move it a little bit further and assume that this is where my table is. So now everything looks good apart from my tool. For some reason didn't show up here. Let's see. Oh yeah, obviously I'm still using the drill here. So we also need to connect that into our simulator. All right, so now you can see my tool and then drill. Everything has been set up. You can turn off the simulation here, Woodbee simulation. Okay, so I think I still have some problem with the positioning of the parts. Yeah, at this point it's just too close to the robot, so let's move them a little bit further and I think my table will be somewhere here. Yeah, that's simple as this. You set up your tool and you convert Woodbee toolpad to KUKAprc toolpad, and then everything is done. We can now watch the simulation. And if everything looks good, we're going to load that to the robot. At this stage, there is no simulation of the milled surface. This is a component that I'm currently working on. It will be published in maybe in the future with the next release of Woodbee, and that will show you the actual surface that is milled if there is a collision with the tool of the robot or anything like that. Also, there's another component that the KUKAprc user can use in order to remove singularities or collisions. So it's something that you can find on our website. If you have a question about, feel free to ask your questions on the forum or direct by email. Thanks for watching and see you next time.